Welcome everyone. Welcome to the course of Digital Logic and Process. This is the first class and the introductory class about our course. Today we'll be discussing about what is a computer, what is a microprocessor, and what are the components of your computer. So if I quickly ask you what is digital and what are the kind of systems that are available in the market, they will be computers, they will be your smart watches, there will be a washing machine, AC, mobile phones. Every day we go through them, lifts, traffic lights, and many such devices. All these devices are categorized into something called digital devices, and they run based on certain logic. So if you see a AC, whenever certain amount of temperature is reached, your compressor is automatically off. Or you set a timer on your washing machine and it is automatically doing the washing process and the drying process for us. So every device we see is either categorized into the logical part of it. Now let us see how they are classified and how they are actually divided. Like I said, there is some kind of input that is received by the system and someone who will process the data and give the output. So this is usually done by something called a processing element. The processing element in your computer actually does that. If you look at the various kinds of processors that are evolved through time, the first ever processors, the early stages of processors happened around in 1950, which contained only one transistor. And if you look at the evolution, the 1960s made of 16 transistors, and 1970s we got the first 8-bit processor. So what is this 8-bit processor? It is able to process 8 bits of information. That means you should be able to add 8 bits of data at a time, or you should be able to multiply 8 bit of data at a time. 32-bit process, 64-bit process. Today our domestic computers still use 64-bit process, whereas bigger supercomputers have lot and lot of GPUs, lot and lot of multi-core processors in it. Now we'll try to understand what a processor is and what are the components inside a processor. A processor is defined by the logics or the blocks it has and the performance it can do based on that. That means a processor should be able to do addition, subtraction, multiplication, comparison, shifting, etc. etc. If you put all those blocks inside a processor, that becomes a microprocessor. Okay, I have a digital camera. So what modules my digital camera will have? My digital camera will have a pixel processing thing. It should have a autofocus thing. It should have a pictures viewing ability. It should be having a storage ability, which this processor might not have. What will my AC have? My AC will have a comparison to compare the outside temperature. It will have a timer to set 2 hours on, 3 hours off. It will have modes. So it will have selections. It will have a small motor to do the swing. That means if you look at a computer, a camera, and a AC, the highest number of jobs is done by your computer. It will do abundant amount of jobs, whereas a camera will do minimal set of jobs. And AC is also specific to its application. That means you can generalize them into application specific and general purpose. General purpose systems are the things that do many jobs, whereas application specific are confined to do only certain amount of jobs. So your general purpose system is your computer and application specific system is your AC, your microwave oven, your parts in your mobile phones, and lot and lot. Now, if we look at how they are designed, they don't have the same kind of processor in it. The processor inside your computer should be more and more powerful, but a processor inside your AC need not be such powerful. So, let us look at something called a microprocessor. A microprocessor is a device which has an ability to do lot and lot of operations. You know the basics, like what does a processor do? A processor is made of your arithmetic logic unit, a control unit, and a memory unit. Why do we need all these things? Arithmetic logic, which will do the execution for us, a control unit to control the flow of execution, and the memory unit to store your inputs and outputs. This is how the categorization is defined. So if you look at this, what happens? So the register set is your memory unit, which contains all the data. So you want to add 12 plus 13, you will store the data in 12 and 13 in the registers. And ALU can be able to do addition, subtraction, and multiplication. You want to do a plus, who will do the plus? You'll write a program like, okay, do 12 plus 13 for me. Your registers will store the 12 and 13, and the plus will be decoded by the instruction decoder and will tell the arithmetic unit that, okay, you have to do an addition now. Okay, I need to use this block, not these blocks. This is done by the control unit. So overall, the processor operations are defined by the blocks that they have. Now, a microprocessor is something which can do lot and lot of jobs which are not specific. So like I said, these are your general purpose applications, like your computers, your mobile phones, your video games. They use processors in it, which are able to do many operations. And one important characteristic is they are modular. You can change your RAM, you can change your hard disk, you can expand your memories, and also if you want to add 4 GB to 8 GB RAM, you can do it in your laptops. So that is something called a microprocessor based system. There is something called a microcontroller based system, which is used in application specific systems like your AC, washing machine, microwaves, and all these things. Do we need to upgrade your RAMs in that? Maybe no. Do you require large set of programs? Maybe no. But is the task specific? Yes. Can it do any unpredictable jobs? No. Unlike your computer, there are the application specific systems are confined to their jobs. They don't do beyond what they are intended to do. But if you talk about a computer, it will be able to do a lot of things. Maybe someone want to play a game, someone want to store photos, someone want to see movies. So the application that it can do varies from one to other, whereas a microcontroller or an application based system is confined to the jobs. In that case, we don't require large set of ROMs, or your processing things. And also, we don't need them to be modular. We don't need to upgrade your RAMs. Do you ever see upgrading a RAM in your mobile phone or upgrading a RAM in your washing machine? No, we don't get that chance because they all come on a single chip. So it means a processor, RAM, ROM, your clock, input output ports, all of them come on a single chip, which is completely different to a microprocessor based system. Where a microprocessor based system, everything comes in a separate. You will have a CPU separately, you'll have your RAM separately, you'll have your ROM separately. Why? Because we need them to be modular, we need them to be expandable, we need them to be more powerful. Whereas these comes with a specific set of operations and do only specific amount of jobs. That is your microprocessor and a microcontroller. And the systems like your computers use microprocessors inside them, and the laptops, desktops, all these things come under these examples, and we usually call them as microcomputers. Microprocessors also drive bigger systems like supercomputers and etc. The things that we everyday use are something called microcomputers. Like I said, microprocessor reads the data, reads the instructions given by the user, understands them, and try to execute them. This is the way the processor is organized. You'll have ALU to execute, you'll have registers to store, and you'll have control unit to tell ALU what to